Welcome to another math problem of the week. Matchstick square. Let's talk about it. For today's question, we have 24 matchsticks that can form altogether 14 square. They are 9 1 by 1 square, 4 2 by 2 square, and 1 3 by 3 square. Now the question asks, what is the minimum number of matchsticks that must be removed so that no more square in the diagram? And the options are A 4, B 5, C 6, and D 7. What do you think?
Pause the video now if you wish to solve it. Keep watching the video once ready.
If we look at this diagram, we look at these 5 square that make up of matchsticks that do not intersect at all. To take exactly only one matchstick from the square A, one from B, one from C, one from D, and one from E. Now we are going to consider some of the cases. No matter how, we will need to remove one matchstick from the square C. So meaning that we need to take either this matchstick or that matchstick. But it is all symmetry. So without loss of generality, I will remove this matchstick. So this is removed. Now, let's say for square A, let's say we remove any of these 3 sides, and so for B, any of these 3 sides, what will happen? So after we remove one matchstick from A, from either one of the side, one matchstick from B, either from the side, we already removed 3 matchsticks. But then, it turns out that we still have a 3 square that do not have any intersection of the edge. And it means that we need to have at least 3 matchsticks to destroy these 3 square. You will have more than 5 matchsticks. So we need to remove either one side here or one side there. So suppose we remove this side. Then we just need to focus on what are the matchsticks that must be remain there if the minimum number of matchsticks that has to be removed is equal to 5. From C, this will be always there already. And from B, this is always there. And we do not remove anything from here. So we also do not remove anything from here. We can focus on this particular 2 by 2 square. So for this 2 by 2 square, it will be only destroyed if we are going to take either this side or this side. So we will have 2 cases to consider. Suppose we remove this matchstick. If we remove this matchstick from square E, then we have to remove this matchstick from square D. Otherwise, we will have this particular square remain. Now it turns out that we will have one more matchstick has to remove from A. But what we have here will be, we only concentrate on these few matchsticks, and we will see that it still forms 3 square. 2 smaller square and 1 big square. We can only remove one matchstick to destroy these 3 square. That is impossible because these 2 smaller squares have a common matchstick that is from here. And each of these small squares has an intersection of the bigger square of a different matchstick. So no matter which matchstick is removed, there must be at least one square remain. So we have to return to the case that we do not consider just now. Just now, we are saying that either this must be removed or this must be removed. And the case where this is removed already been considered, now we go to this case. Now this is removed, what will happen? If this is removed from the square A, it means that this matchstick will be remain, including this. Okay, these three matchsticks will be remain. Initially, this is untouched. Now we will see that there will be 2 by 2 square if we do not remove this matchstick from D. So to avoid the 2 by 2 square remains, we have no choice but have to remove this matchstick from D. So far we have removed 4 matchsticks, and what we have here is quite similar to what we have for the previous case, but the figure turned out to be something like this. We have to remove only one matchstick to destroy these 3 squares. That already been cast, it is not possible. So what we have shown just now is by removing 5 matchsticks, there will be always some square remains. So the answer cannot be 5. How about 6? For 6, it seems that it's possible. We check one by one. Remember, we have 9 1 by 1 square has been destroyed. Destroyed, or destroyed. 4 2 by 2 square. The first one destroyed here, the second one here, the third one, 2 of here, and this also have been destroyed. How about the largest? The largest also have been destroyed. So it shows that 6 is possible, 5 is not possible, and therefore the minimum number is equal to 6, and our answer is equal to C. Later on, I will give you some extension for this problem. And for now, let's look at other people's solution. This is a natural extension. Instead of 3 by 3, now we have 4 by 4 grid. And it formed by 40 matchsticks, consists of 30 square in total. How many matchsticks must be removed so that there's no more square in this figure? Please try this question and check the answer in the description. So we start with 3 by 3, then extend to 4 by 4, and in general, we can ask for what happened to n by n. So we can ask a very simple question. If it's n by n grid, how many matchsticks that we will have? And how many squares that we will form? Lastly, what is the minimum number of matchsticks must be removed so that there's no more square in the n by n grid? I'll give some of the answer in the description. Please try it and check it after that. And that's all for today's lesson. I'll see you again. Bye-bye.